Welcome. This question says an ice skater whose arms are outstretched spins with an angular speed of 6 radians per second and has a moment of inertia of 12 kilogram meter squared. When she pulls her arms in, she spins with 18 radians per second. What is her moment of inertia when she pulls her arms in? So let's visualize. Here we have the ice skater spinning with her arms outstretched. And what do we know at this point? We know that omega initial is equal to 6 radians per second. And we know that the moment of inertia at this initial stage is equal to 12 kilogram meter squared. And then she brings her arms in. So let's imagine that. And we can imagine with her arms in now, spinning like crazy. And angular velocity is now equal to 18 radians per second. And moment of inertia is what I don't know. So I need to find a principle that links these two things. And what with a little bit of thought, what I realize is that, well, she's on ice, so there's no friction, and so she's in an isolated system, and so angular momentum initial equals angular momentum final. Okay, and angular momentum, of course, is equal to I omega. So I can say her initial moment of inertia times her initial angular velocity is equal to her final angular momentum times her final angular velocity. And if I look at my information, I can see that, well, that's going to be 12 times 6 is equal to IF times 18. So IF is going to equal 12 times 6 over 18, which basically equals 4. So IF is equal to 4 kilogram meter squared. So again, mathematically not a hard question, but the idea is that we visualize. I've been doing these things for years, and I still cannot go from words to calculations without making slips every now and then, because I misinterpret. Sometimes I can do it, but I can't guarantee I'll make a reasonably low number of slips. So I always go by a visualization. I always try and list what I know and what I don't know. And that helps prompt me, actually, for which equation to use. We're getting to the stage now where we have so many different tools in our toolbox that, you need a saw, but you don't know which saw you need. And if you're not careful, you're using the wrong saw for the wrong job, and the work comes out being not very good. So by visualizing, I become more efficient, and I use the right relationship for the right job. I get to my answer much more quickly, and my work standard improves. It's time on task. It is as you get more and more relationships coming more and more quickly, it's spending time with them so they become familiar enough that you can select them when you need them. And that's the job. So there we have it.